So today we're going to look at how can we find a trig function given another. So we're going to solve problems involving trig ratios in the unit circle to find the exact value of one trig function given another. So if we can start by looking at it from our exact values. So here if we go back to our triangles, so let's go here with our green one to start with. Notice here that if I have a right angled triangle with 45 degrees, then my sides are 1, 1, and root 2. And what you'll notice is that sine, so opposite over hypotenuse, is the same as cos, which is adjacent over hypotenuse. And that's what you can see. And this is just with the denominator rationalized here and here. So these two values are actually the same. I also want us to look at our other exact value triangle. We've got our right angle, we've got 60 and 30, and then here we have root 3, 1, and 2. Now what you'll see here is let's just take sine 30 degrees. Notice that's opposite over hypotenuse, which is our half. And then if I take cos 60, which is adjacent over hypotenuse, I get the exact same answer. Recalling that cos stands for cosine, which is the complement of sine. So its complementary angle to sine will give us the same value. So we're going to continue with this with a question here, and we're going to consider the unit circle in our practice question. So if sine theta is equal to 1 over 2, find the possible values of cos theta. So recall here, we've got our unit circle. We've got all stations to central. Now, the first thing I'm going to do is I'm going to make a right angled triangle in my unit circle. So here, this is going to be my theta. Now here, according to here, I've got opposite over hypotenuse. So I've got opposite over hypotenuse, and notice that that is giving these values right here. So here, that means that this side here adjacent to the angle is going to be root 3. So here, if I were to take that same triangle and I were to use it for cos, well, that there would be, adjacent over hypotenuse. So root 3 over 2. Now recall that with our all stations to central, think that our 1 over 2 is a positive number, and recall that sine is also positive in this second quadrant here. So we're going to draw a triangle again. Here we're going to have theta still because it's still positive, and notice that when theta is in this second quadrant, it's also equal to positive 1 over 2. But what you'll notice here, we still have root 3, but notice here that sine is positive, but cos is negative. So here what we're going to get is we're also going to get that cos theta is also equal to negative root 3 over 2, where the negative is telling us that we're in a quadrant of the unit circle where our cos trig function is actually going to give us a negative output. So notice that given that we have sine theta is equal to a half, we can actually find our other trig values, in this case such as cos. So we're going to continue with this with our next example. So here, if cos theta equals 1 over 5, part A says find the possible values of sine theta. Now, my first thing I notice is that unfortunately, 5 is not in any of my exact value triangles. So that's okay. So what I want you to think about is your first step is always make a triangle. Your second step, we're going to look at using Pythagoras. And then we're going to find the other trig function. So those are our 3 steps that we're going to look at when we are solving these types of questions. So step 1, I'm going to make my triangle. And in this case, I have the unit circle with me, but you don't need the unit circle, and you'll see this in our later examples. My triangle here, my adjacent side is 1, and then my hypotenuse is 5. So to find the opposite side, here let's call that x. actually, we'll just call it let's call it A. So A squared is equal to 5 squared minus 1 squared. So A will be equal to the square root of 24. So that does simplify, I believe, to 2 root 6. So here for part A, I'm going to use that same triangle, and now I'm going to, instead of using A, I'm going to use 2 root 6. So sine theta will be equal to opposite over hypotenuse. So opposite over hypotenuse. Now recall from before, our unit circle, we have all stations to central. So we're going to repeat these same 3 steps, but now we're going to look at cos is also positive in the 4th quadrant. Sorry, it highlighted all of that there. So here I've got 5. This is going to be 2 root 6. So here for our pink option, which is in the 4th quadrant, notice that cos is positive, but sine will be negative. So that will also be my second possible answer. So those are the 2 possible values for sine theta. Notice the question gives you a hint with the word value being plural. Our next part is we're going to take a look at question B. So now it says find the possible values of sine theta if tan theta is negative. Now notice here that the first thing I'm going to do is I'm going to circle the quadrants where tan theta is negative, which is quadrant 2 and quadrant 4. So here, notice that I have to satisfy all the criteria. So the first criteria is that cos has to be positive. So I'll actually write this down here. So cos theta has to be positive. And here, tan theta has to be negative. Now what you'll notice here is that, can you see in quadrant 4, both of these criterias are satisfied. So here, to find the possible value or values of sine theta will only be negative in this quadrant here. So I'll do it sort of like this. So here, sine theta will be negative. So to recap, I'm going to look back at part A. To find another function, first step is to make a triangle. Your second step is to use Pythagoras to find the unknown side. Your third step is to then find the other trig function, considering what quadrants it's in. Now here, if I get to something like B, where I have to consider a second set of criteria, then I need to find a quadrant that satisfies cos being positive and tan being negative. And the only quadrant that does that is quadrant 4. So if I focus on that quadrant and I need to find a solution for sine theta, then sine theta has to be negative in that quadrant. So now let's have a look at our next one. So feel free to pause the video if you want to have a go at solving this one yourself. Otherwise, I'll keep going through with a worked solution. So remember here, our first step, so step 1, let's do that. Let's maybe make this red. Step 1's to draw our triangle. So theta, I've got opposite over adjacent. Notice now that my second step is I need to use Pythagoras. So let's call this side C. So C squared will be 5 squared plus 2 squared. So C will be just the square root of 29. And then finally, my third step is for me, actually I might actually draw it over here. My third step is to find sine theta. Now here, all stations to central. So here, sine theta will be equal to opposite, which is 2, over hypotenuse, which is the square root of 29. Recall that I also need to consider where tan theta is positive. Tan theta is also positive here. And in this quadrant, tan theta is positive. Actually, I might write it like this. But sine theta is actually negative. So my other possible value for sine theta is also minus 2 over root 29. You also might find that some textbooks or some wet solutions, they also might write their answer with a plus minus symbol. So just as an FYI, that means the same thing. So now we're going to have a look. Now with these examples here, feel free to have a go. Now these ones, they don't give us the unit circle, but we don't need the actual drawing of the circle to solve these ones here. So here I'm looking at question 1. So let's start with question 1. I'll see, actually, I might just do a new page here. And then I might just quickly white out just that bit so we can have a bit more room. I'll just use the tape. There we go. So here, what we're going to do now is, given that tan theta equals negative 5 over 12 and theta is obtuse, find sine theta and sec theta. So here, the first thing I'm going to do is, I've got setting up my all stations to central. And then I'm going to cover my criteria. So here, first of all, I've got tan is negative. So tan theta is negative in the second and the fourth quadrant. Now it also says that theta is obtuse. So notice with the unit circle, we start at 0 degrees, 90 degrees, and then 180 degrees. So can you see that the angle then must sit in this quadrant here? So I've just done a double circle there to emphasize that. So now that I know where it is that my angle is sitting in, I now need to look at finding sine theta and sec theta. So let's start with sine theta. So remember, our first step is to draw our triangle. So here I've got theta. Now remember, I've got opposite over adjacent. So here, our C value is going to be equal to 12 squared plus 5 squared, which thankfully gives us an integer of 13. So here for sine theta, now thankfully sine is in the second quadrant positive, so our answer is going to be positive. So here it's going to be opposite, and instead of C now, I'll just move this here. Ooh. Let's make that 13. It will be 5 over 13. My next one I'm going to look at, now recall here sec theta is the same as 1 over cos theta. So it is the reciprocal. So if I know that cos theta, I might move it down here, is equal to adjacent over hypotenuse, well then sec theta must be the reciprocal, which will be 13 over 12. Now what you would have noticed as well is that there's actually one thing that I'm missing from my final answer here. Now here, sine theta is positive in this quadrant, but unfortunately cos theta is actually negative. So in my final answer, I'm going to make sure that I have a negative with it. So my final answer is that sine theta is equal to 5 over 13, and that sec theta is equal to negative 13 over 12. So now let's have a look. We're going to have a look at a similar question. So I'm just going to wipe this bit out here, so that way we can just focus on this one. So here it says, if theta is a reflex angle such that tan theta equals 2 over 3, find the value of cos theta. So I'm going to draw up my unit circle. My first bit of information is that theta is a reflex angle. So here that means it's either sitting in this quadrant or it's going to be sitting in this quadrant here. So it says that if it is a reflex angle such that tan theta is a positive output. So can you see here, then it must be sitting in this quadrant because that is the only quadrant of the two where tan is actually positive. And now my next step is to follow the 3 steps of solving for cos theta. So remember, our first step is to create a triangle. Now here I've got opposite over adjacent. So here, to find what my C value is, I'm going to then use my second step, which is Pythagoras. Four and 9, so the square root of 13. Now then my third step is to find the unknown trig ratio, which is at cos theta. So cos theta, the thing I'm going to consider is, can you see that in this third quadrant, cos theta is negative. So my answer will be minus the adjacent side, which is 3, over the hypotenuse, which will be the square root of 13.